Hey everyone, welcome back. Today, we are going to dive into something you will use constantly as a Python programmer, the list. Seriously, if you need to organize, well, pretty much any kind of data in Python, this is where you start. So just think about it for a second, and pretty much any program you write, you're dealing with groups of things, right? A bunch of usernames, a series of temperatures, maybe the high scores for a game. How do you actually keep track of all that stuff in a clean, manageable way? Well, in Python, the go-to answer is the list. And I absolutely love this analogy. It's the Swiss Army knife for your data. Why? Because it's ordered, it's changeable, and it couldn't care less if you have duplicate items in there. Those three things make it unbelievably useful. All right, so let's really pull this apart and see what makes a list, well, a list. So there are a few core ideas you've got to get. First, they are ordered. This just means that if you put an item in the third spot, it stays in the third spot. Second, they're mutable, which is just a fancy word for changeable. You can add stuff, remove stuff, swap things around after you've made the list. And yep, you can have the number 5 in there 10 times if you want. Duplicates are totally fine. But you know what's really the killer feature? They're flexible. You can toss a string, a number, and a decimal all into the same list. It doesn't care. Okay, so that's the theory. But how do we actually do stuff with them? Let's look at how to build one and then, get our data back out. Honestly, it's about as easy as it gets. You just give your list a name, use square brackets, and pop your items inside, separated by commas. And boom, that's it. You've officially made a list. Okay, cool. So your data is in there. But so what? Data isn't much use if you can't get to it. How would you grab just that first number, that 10? Or maybe more tricky, how do you always get the very last item no matter how long the list is? This is where indexing comes in. And here's the one thing you have to remember about Python and a lot of programming. We start counting from 0. Not 1, 0. So the very first item is at index 0. L10 gives us 10, L11 would give us 20, and you get the idea. But wait, it gets even cooler. Python has this amazing feature called negative indexing. You can count from the end of the list backwards. So -1 is always the last item, -2 is the second to last. This is a total lifesaver when you just need the last thing in a list and you don't want to bother figuring out its length first. Okay, but what if you want a chunk of the list, not just one item? That's called slicing. You give it a start index and an end index. But, and here's the part that trips everyone up at first, so listen close, it grabs everything up to, but not including the end index. So L1, 1/4, gives you the items at index 1, 2, and 3. It stops right before index 4. All right, you know how to build them and read them. Now let's get to the fun part, manipulating them. Python gives you this whole toolkit for messing with your lists. You can actually use operators you already know, like plus and multiply, but they do something a little different here. The plus sign smushes two lists together. That's called concatenation. And the multiplication sign just repeats the list over and over again. They're super handy shortcuts. Okay, I want you to pay close attention to this next part because it's a classic gotcha for people new to Python. We've got two ways to compare things, the double equal sign, double equals, and this little word is. They look like they do the same thing, but they absolutely do not. So here's the difference. The double equals, asks, do these two things have the same stuff inside them? But is asks a much stricter question. Are these two variables pointing to the exact same object in my computer's memory? It's the difference between having two identical copies of a book versus having two different names that both refer to the one single book. And this slide just lays it out perfectly. To save memory, if you create two simple strings that are identical, Python will often just have both variables point to the same one. That's why A is B is true. But for lists, because they're changeable, Python plays it safe and creates two totally separate objects in memory, even if they have the same content. That's why A is B is false for the lists. They're equal, but they are not the same object. On top of all that, Python has some super useful built-in functions that just work. Want to know how many items are in a list? Len. Need the biggest or smallest value? Max and min. Need to add up all the numbers? Sum. These are your quick and easy wins. But it doesn't stop there. Lists have their own special built-in functions called methods. These are actions the list performs on itself. You can append a new item to the end, remove an item by its value, or pop one out using its index. Now, this is a big deal. A lot of these methods, like sort and reverse, change the original list. They don't give you a new sorted copy. They modify the list in place. Okay, so you've got the basics down, you're building lists, you're changing them, you're doing great. But now let's talk about how to level up your code and do things in a really elegant, Pythonic way. And this is a list comprehension. Just look at the difference. On the left, you've got a perfectly fine for loop. It works, it takes 3 lines. On the right, the list comprehension does the exact same thing in one single readable line. It lets you build a whole new list based on an old one, all in one shot. Now, I know the syntax looks a little backwards at first, but it's actually super logical once you see the pattern. You start with what you want to do to each item, the expression. Then you write the loop for each item in your list. And if you want, you can tack on an if at the end to filter things out. And this is where the real magic happens. By adding that if condition, you can transform and filter at the same time. In a single, beautiful line of code, you're looping through a list, checking a condition, and building a completely new list with just the items you want. It's awesome. All right, so let's just pull it all together. First, lists are your #1 tool for ordered data, period. To get that data out, you gotta master indexing and slicing. To change your lists, you've got a whole toolkit of operators and methods. And finally, if you wanna write clean, professional code, you can totally level up your game with list comprehensions. So there you have it, the Python list. It really is the Swiss Army knife of data, and now it's in your toolbox. You can use it for anything from tracking player stats in a game to analyzing weather data. So the only question left is, what cool problem are you going to solve with it first?